Now let's demonstrate this tree in action. So we have a main method, and we have a tree, which I just called tree, and we have a attribute called, which is a variable called done, and this allows you to continuously input numbers until you want it to stop. So first we have to set root to null, so we're just creating a root of the tree, which is nothing because we don't know what it is first. Now we want to ask the user to input the root node. This is calling the scanner A. It's going to get the user input and store it in this variable here. So then we create the actual root node. Root is tree.addLeaf. Then there's this input here, which is the user input, and a root. So this is the actual number. So example, I want my root to be, say, 10. I input 10, and it would make a root with value 10. So now there's a while loop, just runs until the user wants it to stop. So we want to have an input, and this is my sort of kill function. So if it's a negative number, then it just ends the loop. If it's not a negative number, then it will add a leaf, and it will input this, the user input, and it will input the root. So let's see how this works. Let's run the file. Okay, so let's put in 10. So let's say I want to put in 3, and it will show the infix, prefix, and postfix. I want to input, say, 4 now. Now 1, now 56, now 421, now 68, now 45, and it works. And let's put a negative number to end the input. Now let's go search for a number. So let's see, 421 is in the tree. Let's go search for that now. 421. Number 421 is inside the tree. First we have the pre-order traversal, and this is where it will print out the number and then recurse left and then recurse right. So let's show an example of this. So firstly, we start at the root node, it prints the number. Let's recurse left. Goes here, prints the number. Let's recurse left again. Prints the number, recurse left. Whoa. Recurse right, print the number, recurse left, print 6, recurse right, print 9, recurse right, print, recurse left, print, and recurse right, print. So the order that would be printed out would be 10, 5, 2, 8, 6, 9, 15, 13, then 19. Now, let's talk about the in-order traversal. Now I'm going to demonstrate the in-order traversal. So the in-order traversal is where you recurse left, then you print, and then you recurse right. So recurse left to 5, recurse left to 2. I can't recurse left anymore, so let's print. Okay, let's go back to 5. Okay, we've recursed left on 5. Now we can print on 5. Now let's recurse right. Let's recurse left on 8. We can't recurse left on 6, so let's print 6. Go back to 8. Okay, we can print now, so you print 8 and recurse right on 8. 9, we want to recurse left. Nope, we can't recurse left, but we can print it. And we go back to 10. 10, we can finally print because all the left traversal is complete. Now we can traverse right. So traverse right to 15, 15 traverses left to 13, 13 cannot traverse left, so it prints. Back to 15, 15 can finally print now, and finally 15 goes right to 19. 19 can't go left because it's a leaf, so it prints and it cannot go right. So this order would be 2, 5, 6, 8, 9, 10, 13, 15, 19. And if you noticed, this is actually in ascending order. So the postfix notation has each node recurs left, then right, and then finally it will print. So 10, let's recurse left. 5, okay, it can recurse left, so let's go to 2. 2 can't recurse left or right because it's a leaf node, so we can print it. Back to 5, 5 can finally recurse right, so let's go right. 8 can recurse left to 6. 6 cannot recurse left or right because it's a leaf node, so let's print 6. Back to 8, 8 can now recurse right. Now to 9. 9 is a leaf node. Again, leaf node you can't recurse left or right, so print it. Now we can finally go back to 5 and print 5 because we have recursed through 5's left subtree and 5's right subtree. We go back to 10. Okay, so we've recursed through all of 10's left subtree, so let's go right now. So, goes to 15. 15 can recurse left, so it goes to 13. 13 is a leaf node, so let's print it. 15 can recurse right now to 19. 19's, again, it's a leaf node, so we're going to print it. Okay, we recurse through 15's left subtree and 15's right subtree, so we can finally print 15. And now we've recursed the whole thing, and we can finally print the root node, which is 10. So in this scenario, we will have, in this order, 2, 6, 9, 8, 5, 13, 19, 15, and finally 10. One last look at the code. Here is the infix code. So while it's not null, so while you can still recurse, recurse left, print, recurse right. Same thing with prefix, print, recurse left, recurse right, and for postfix it is recurse left, recurse right, and we print.